Hello everyone, hopefully everyone can see and hear me okay. Hello, how are we doing tonight? Yes, this is live and we are doing a live tutorial today. We just came out of a day of celebrating my birthday. My birthday was yesterday, so thank you to everyone who sent me birthday wishes and birthday messages. It was nice to see all those messages, so thank you so much. If you're just joining us tonight, what we're doing tonight is a live tutorial on how to create a spaceship fighter game, focusing mostly on targeting. Okay, so that's what we're going to look at trying to do tonight live. Yeah, before I get into that, I'll do some basic housekeeping stuff. So first of all, thank you to all my patrons and thank you to everyone who's been supporting me on Patreon and who's joined Patreon this month. Thank you so much. It means the world to me. Thank you. And if you want to be in the one-to-one tutorials, we do have some slots open for November. So if you want one-to-one tutorials, you can find more details over my blog on riley.com/blog. I have chat open on window over here as well. So hello everyone in chat. Hello Gennard Pointnik. Hello Olimar David. Hello Mimi Victor. Hello everyone. How are we doing? Hope everyone's all safe and well. Okay, so I'm just going to jump straight in because we've got quite a few things to do. So, hopefully this is working. My switch is going a bit weird. Let's just make sure that's all gone through okay. It has. Excellent. Okay, so today we're going to make a space shooter focusing on targeting. But for that I needed a spaceship. So I found a spaceship I modelled a while ago for another project. So I brought this in. Very simple, cartoony, blocky ship. So we're going to try and use this for our game here. So first of all, we need to get a ship moving and able to fly around so we can actually do targeting stuff. So thank you everyone. Hello. So okay, so we're going to create a new blueprint class and we're going to choose a pawn character here, and this will be our spaceship. So it goes spaceship and open it up. And in here we have to set up obviously a mesh. So I'm going to go skeletal mesh because that's what it is. And choose the ship over here on the right. Okay, there's our mesh. Alongside that, I'm going to put a... actually, no, we'll leave it like that for now. Okay, so we've got this. We also need to do pawn movement. So we'll do floating pawn movement. Well, in fact, we could just make it a physics-based object. That'd be better. So we're going to remove this, actually. Now, if you're making it a physics-based object, you want your mesh to be the main route. Okay, so we're going to scroll down and tick Simulate Physics, and click Compile, and close that. Now, for it to fly around in this world safely, we need to make sure we turn off the world's gravity. So, in your world settings, which usually is down here, if it's not, you just go up to Window and World Settings. And in here, you can override the gravity. Override world gravity and set to 0. So let's put this into the world. I'm just gonna make this thing just stand out, making it not be lit. So make it unlit. Apply that. I will go quite fast, by the way, because I say I've got quite a lot to get through. So hopefully, oh hello. Oh, I've got to plug it in the wrong way. That's why. There we go. And close. Yes. Hello, Energy. Hello, Matteo. Hello, Ice Karim. Okay, so there's our spaceship. Looking a bit dull in this setup we got here. Nonetheless, right, so to make this thing accessible, we're going to scroll down here, search in the details box, auto process player, player 0. So now, oh, we ain't got a camera on it yet. We've got to put a camera on it. Yep. Okay, so I'm going to add a spring arm to this thing. And on that, we're going to have the camera. Okay, let's increase the length of the spring arm. Do that. And I'm also going to give it a bit of a lag in it. Enable camera lag, rotation lag. And we'll leave the settings like that. And close that. Okay, let's mash it. We're going to get an error. It's set to simulate physics, but collision enabled is incompatible. So the reason why that's incompatible is if you go to the mesh, scroll down here, it says it's got no collision on it. So in here we need to add collision to it. So we're going to go, we'll do overlap all dynamic for now. I don't know, do block. We do block. And click compile. And let's see. That clears that error for us. Yeah. Okay, that clears that error for us. Right, now to get it moving. So in here we need to set up our inputs and get it flying around. So project settings. So the lag on the camera, what it does is when you are moving, say if you move, the camera will like lag behind it a tiny bit, and it gives that impression that your camera's trying to chase and follow it. And rotation lag does the same thing. So when the camera turns like that, when the player turns like that, the camera will have a slight delay in how it follows it. It just makes it feel like the camera's sort of floating behind it and chasing it around. Makes it a bit more interesting to look at. Okay, so axis mapping, we'll do action mapping as well. Axis mapping, we'll do thruster, and that'll be W, and that'll do for that. And for we'll do yaw, will be handled by the D key, and no, not yaw. That'll be handled by the mouse. Mouse X, and then we do pitch, and the pitch is going to be the mouse Y. And we'll make it -1 here because we're not doing inverted, so we'll do that. And here we've got roll, and that'll be handled by the D key on the keyboard, and the A key on the keyboard, with A being -1. Okay, that would do for that. So let's get thrust working. Thruster event. And in here, we're going to add a force to this thing. So I'm going to add force. And we'll do add force to mesh. And because the mesh is the root, everything else will go with it. So the force we're going to do is in the forward vector of the thing here. So we get actor forward vector multiplied by float. And we're going to multiply it by this axis value, and we are then going to multiply this again by another float, and this will be the amount. So this is how powerful of a force you're going to put onto it, and this is just going to take some guesswork because we don't know how it's going to play. So I'm going to put 10,000 in for starters and see how fast this pushes us, and then from there we should be able to figure everything else out. Not fast at all. Okay, let's up that a bit. Let's put a couple more zeros in it. Also, let's turn down the weight of it as well. That'll help. Or any constraints, actually. Should be okay. Right, 2 extra zeros. Let's see if that done anything. A little bit. We got some thrust. Okay, I'm just going to change that to 9. So it's 9 times more powerful. There you go. Now we've got thrusters. Just going to rotate the camera a bit so we've got a bit more interesting look. Okay. Bit too high, I think. We'll keep it like that. Okay, now to the other ones. So we've now got to do pitch. So the pitch has come from the mouse, and we're going to rotate the mesh or turn it. And to do that with a physics-based object, I'm not too sure. Let's have a look. So set rotation, actor rotation. Oh, actually no. We'll do add pitch, add controller pitch input. Let's see if that does it. I don't know if it will or not. We should have it inherit. Use controller pitch. Right, push play. Nothing. Oh, hello. Attempt to move a civilization. Please use teleport flag. Ah. We don't have a teleport flag because we're adding pitch. Let me just Google that one. Right, let's have a look. Just seeing what documentation there is for. Oh, okay. It is set physics. Physics angular velocity. There we go. We'll do it in degrees. Sure. Do that, and with the experiment with this one, we'll do that. So when we do pitch, we want to take this value, multiply it by a vector, and multiply it by a vector because this is going to be -1 or to 1 based on which way the mouse is moving, and we want to change it in the pitch, which would be in the y-axis. So we want to multiply this by, let's try 1000 for now. That's too high or whatever. Whoa, too high, too high. Right, yeah, it's too high. Attempt to move a simulated mode. Please use typical flag. I am trying to move it. Eh. Alright, let's turn it down. Let's go to 400. I'm not trying to move anything, so why is it? So we've got a spaceship flying. So you see that lag going on, and that's what that's doing. Okay. This is annoying me. I don't know what. I'm not trying to move anything. The only thing I can think of is we're telling it to use controller pitch. We'll use that. Turn it off. I think that would be the problem. Yeah. Okay, so we got that. That'll do for now. Next we're going to do is, let me turn the chat back on so I can see. Okay, so we got pitch. Now we have to do yaw. Copy basically all that again. This time we want to change it in the yaw be the Z. But this one's gonna be less sensitive, so let's do 100. Compile that. Not getting nothing. Let's try. One thing you have to double check if you're doing angular things. Yeah, make sure you've got no constraints on the rotation. No. So let's up this a bit and see if that affects it. What? I'm just going to disconnect pitch for now, because I'm scared that that's breaking it. Right, there you go. Oh, right, I see the problem. Okay. Here's the problem. It's trying to do these two separately and overriding each other. Or this one's more likely overriding this one. So what we have to do is combine these into this. So, here's my plan. So we do pitch, yaw, delete that, and delete this. And we need also roll. And we're going to multiply each of these axes value by the one we want. So we're going to do that. And that. And this one would be Z axis. So, but I don't want it to be as sensitive. So I'm going to do it at 100. This one as 0 and X as, again, not sensitive, so 100. Again, this is all going to be tweaked. So when you do any of these, we're going to add vector plus vector, add all three of them together, and this is my theory that we can just plug then this into here, and let's see, because the thing is with the axis events, these happen all the time. It's not like an action event, so all of these need to call the same thing. So there you go. Now I've got a spaceship. Very hard to control. Right, okay, so one thing I've got here is pitch is going by, it's going by the world angles, not the world coordinates, not the local coordinates. So pitch up and down here, if I was to rotate like this and I pitch up and down again, it rolls it. So these have to be localed. So we're going to transform this vector here. Transform. Transform. We want the inverse. So we'll do inverse direction. Why not? And get actor transform. No, don't act. I don't actually. Let's try that and plug that in. I think we might get transform of the mesh, not the actor. Let's double check that. Okay, so if I were to roll it. Okay, cool. Nice. I know it's a bit janky, but it's something to play with, I guess. I'm going to turn down the lag on this spring arm. Let's find the spring arm lag. Change it down to like 2. And we'll do that. Oh yeah, because we slowed it down, the speed. We want to speed it up actually. Let's put that to 10. No, yeah, that one's 2. What do I want to do? I don't want to do that. I want to do higher. So that would do 30, 30. And hopefully that'll keep the camera a bit more where we want it. It's not perfect because ideally I want to lerp between these values. And these, it's a bit janky. Let's turn the rotation lag down to like 2. So there's that rotation lag where the camera sort of lags behind the turning of the thing. I'm doing that on my keyboard. Pitch, up, down. I might turn that down a bit because that's a bit too sensitive. And we've got your left, your right. I'm going to turn down the pitch here to 100. Okay, let's see how that looks. It does do this weird turn though when it does. I don't know why. Why would it do that? So I'm just pushing it up. It's turning like that. Okay. Couple of things I'm going to fix in here is on my roll here. I'm going to switch these around. So that's -1 there. And that's 1. Pitch, I'm going to turn back to 1 there. So I invert the controls. I just prefer it. But let's play this. Oh. So do that. Don't know. Right. Something feels weird with it. I'm trying to figure out what feels weird. Like that turn is not perfect. Maybe if I use the no. I don't want the transform. I want the meshes transform. Maybe let's try that. Transform. Get world transform. Because the mesh is the thing that's doing stuff. So again, got a weird turn to it. It like turns it. I need to output what these are getting. So let's figure out how to do that. So tick. I'm going to do a print string. And on the print string, I'm going to get the pitch. Get your. And these are access values that come from this. So these get my inputs here. Get roll. Okay, and we're going to make vector. And we'll plug X is roll, Y is pitch, and your is Z. Put that in there. Change duration here down to 0.5. And click compile. So let's see what's going on here. So when I push up on here, why is that slightly rolling? Is that the Z axis that's doing that? So the Z axis was being handled by the yaw here. So if I turn that off and leave that at 0 for now. The Z axis is still doing its thing. How's it doing that? Oh, it's because I'm still getting yaw here. But it's still doing it here. Why is it doing that? Oh. Hello, oh my god, ferrets. You think the issue is the camera? It will be a video afterwards, Epic, yep. Do you know C++? Yep. Okay, well, we'll carry on anyway with our targeting thing. We'll come back to making it feel good. Okay, so targeting. So we need a widget. So we call this one targeting widget. And open it up. So let's design our target widget here. So I'm going to get rid of the canvas panel. And in here, we're going to do a size box. And I'm going to override its height and width. And just put in 64 by 64. And we'll change that to desired so I can see what the hell's going on. Next, we're going to put in, for now, we'll just put in a border. Doesn't really matter. We'll replace that with an image later on. And just so it stands out a bit, let's change the color of it to green. Okay. Next, we need a target. So I'm going to make a new blueprint actor here. We'll do test target. And on your targets, you would have a widget component. And this widget component will have, on the right hand side here, you can choose which your widget class you want to use. And you want to choose your targeting widget. There it is. But instead of doing it like that, you want to change the draw size here to 64 by 64. And or tick draw desired size, probably easier. And then change the space from world to screen. Okay. Yeah. Yeah. So hit compile. I'm just going to move that above the head of this thing as well. Let's add a static mesh to this. Just give it, I don't know, cube. That'll do. Widget, we'll put above it a bit more. Okay. So let's put this into the world. Put on the table. I'm going to move this thing back a bit. So push play, see that green thing, and that'll be the targeting space for it. And if we, I've turned off. No, where's my Z gone? Oh wait, I didn't put the number back in, did I? Yeah, 100. Play. So if I turn. What the trick is we want to do now is make that green square remain on the screen and be an indicator based on where it is in the world. So we're going to have to clamp its position. So, the way we're going to do that is on the target widget here. So I'm just looking at chat over here, see what people are adding, if there's anything particular. Okay, you'll carry on. Right, so let's have a think how we do this. I haven't done this one before, so let's see if I can get it working. So on the event tick of this thing, we need to always update and check its location. You can get the deproject screen to world. No, project screen to world. Sorry, project world to screen. That's what we want. Okay, we get the world position and then output to the screen position. So we're going to get the get owning. No, get parent. No, what is it? Get actor. Well, maybe not. Traffic. If we do it on here, probably on the character then instead. Probably on here. Okay, let's try it on here. So on event tick, we're gonna get that widget. So drag that widget out, and we'll be using that. So here we need that project world to screen. Gets the projected world. Hang on. Gets the projected world to screen position for a player, then converts it into a widget position, which takes into account any quality scaling. Oh, okay, let's check this out. So get player controller. World location is going to get this actor's location. Get actor location. That's fine. That's only if you're doing like split screen, which I'm not fussed about. Okay, so widget, we need to change its positioning on the screen. So on here, set position. No, set location. Yeah. Alright, get widget. Get user widget object. From here, we set the position in viewport. Plug that into tick. And let's plug that straight in as like that for now and see what that does. Okay, so it hasn't broken it, which is good. It's always a good sign. Now we need to clamp it. So for that, we're going to clamp this value. So we need to split this to get the X and Y. Then we have to get the viewport size. There we go. Split that. And we're going to have to clamp this value. Oh, if I could spell it correctly. Clamp float. And we're going to clamp the minimum to be 0 and maximum to be X. I think this will work. Split that. Then plug that into there. Clamp. Float again. But the value is there. Max is there. And plug that into there. Okay, so let's see how clamp works. The answer is not at all. Okay, let's get a print string out of that. Let's see what's going wrong with that. Need to turn off this print string first, though. Print string. Make vector 2D. Put that in. Change this to 0.5 and click compile. It has clamped it. But The value has been clamped, but it's not moving it. Have I done something stupid and not figured it out? Set widget position viewport. That's it. Change to 0.1, not 0.5. Hello, Jake. Hello, everyone. We are doing a video tutorial on a live tutorial on how to do a spaceship flying game and do targeting for it, so the targeting vertical doesn't go off the screen. So going through the motions of that. So at the moment, I've got clamp working with the clamp value, but the value isn't updating the position, which is weird. Let's do it something extreme here. I'm going to just clamp this to something really low, to 200, for example, and clamp this to also like 200. And let's just see what that does to it. Nothing. So why is that not working? It's this bit that's not working. This set. Plug those back in. That sounds like it does work. Sets the widget position in the viewport. Position, yeah. Set. Render. We'll do render translation, I guess. Or once we've got that, let's see if it's actually moved it. If I get the widget position, get position. No. Type in position. Oh, you got set. Thanks, Andrew. What am I getting wrong here? Let me just play it in a separate window, because maybe it's doing something weird based on the... The values are clamping. So why the hell is that not... That set doesn't seem to do what it wants to do. Sets the widget position in viewport. Pretty simple. I don't understand why it would have any trouble with that. Is there any setting on here they have to turn off? Let's have a look. Nope. I know the logic of that makes sense. No, underfunded scientists, because it's a widget component and they're added to the screen already. I'm just trying to think, would it be the case that the widget component wouldn't work, but then I know what we'll do. We'll get rid of the widget component off this thing and delete all that. Let's try a different approach. So let's make a HUD. And on the HUD here, we're going to add our targeting thing as a user created thing. Like so. And click size to content. Hit compile. Now for this thing, we're going to change its position in the X and Y based on its location in the thing. So in my HUD here, we're going to add a new variable, and this will be target, and that'll be an actor that we're targeting. And on the tick, we want to get target, check if it's validated, meaning if we actually got one. So if we have a target, we want to change the location of our targeting widget. So drag targeting widget out, and we want to project. What's it called? Project world to screen. Yeah, do this one. Get player controller. Get the world location, which comes from this target. This way, this feels like it's going to work. Get actor location. And we're going to then tell this thing to set position in viewport. And we'll do, let's just see if this works first of all. So do that, and it's valid, goes to there. Okay, hit compile. Then on our player spaceship, we're going to, on begin play, create widget and add it to viewport of the HUD, and let's promote that to variable. Add to viewport. Right, so oh wait, I need to tell this thing to be hang on. I need to tell it to target this. Get test target. Okay, we'll do this. This is a bad way of doing it, so don't do this in future, but we're doing it for testing purposes. Get actor of class. Get test target. And HUD. Set target. There. Okay, let's see if this works. Okay, it's drawing the green square, which is good. But it's not changing its position. You son of a bitch. Okay. Why won't you move? Right, let's print string this thing. Yeah, it's doing it, but it's not actually moving it. Maybe it's just this node. It just doesn't like this node. Yeah, maybe set render translation instead. We'll try a render locator. I don't like the idea of that, but we'll do it anyway. Transform. We'll do it with this instead. So do it in translation. So now it's gone completely. Oh, hello. 0, 0. Oh, okay. I think it was there. It was just off the screen. Hang on. Push play. Random. At least it moves. Okay, so I need to deproject. Right. Let's think about this. I need to project world location to a widget position. I'm getting the location of the actor into a widget position, which is this. We're then changing its render transform. Its render transform here. Oh, I think I know. I have to offset it back to 0 up here. Change its position here to 0, 0. So it's in the top corner. Pretty damn close. Okay, so now we've got to clamp it. Okay, let's clamp this bitch. So, split that. Clamp. Clamp. Get viewport size. Split that. X into here, Y into there. And translation, split that and plug that into X, that into Y. I don't know what's wrong with that set positioning the widget into viewport. I don't know what's wrong with that. If that's a bug, maybe. It seemed like it was doing nothing. So, hey ho. Right, let's see if this works. Okay, so all we have to do then later is just change its alignment and stuff like that, but there we go. And now it's clamped to the screen. Got a weird clamp there. Right, the viewport size clamping is a bit weird. It's not reading the viewport size correctly. Is that because I'm in a different window, maybe? Let's select the viewport. No. Okay. I don't know why the Y is being so broken. Right, let's right. Okay. Right, we'll click on targeting widget, change the alignment here to 0.5, 0.5 size, that's all fine. Right, don't get that. Don't get why the Y value is so busted. Right, so I've got something, it may be something to do with the scaling of it. So get viewport scale. Right, we're going to recombine that. We're going to multiply that by float by this scale here. Then split this and see if that fixes something. No. No, that's worse. Just type in 1. I'll go through in a second so you guys know how to replicate the clamping thing. Just don't get why this viewport business is a bit weird. What? Right, let's just split that again. Type in size. Do I get anything special here? No. Desired size. No. Nothing useful. Right, this should be it. This should be what you do. Yeah, the only thing I can think of is maybe you can get maybe the canvas panel size. I don't know. Like the zeros work because obviously they're 0. Like Y there works and X there works. But as soon as we go, it looks like when it goes halfway in the X and halfway in the Y. So maybe, but that's not always the case because if I do in a new window, it goes beyond that to about there, which makes no goddamn sense. And that's disappeared completely. Oh, it's probably because it's the actor's been occluded, maybe, or no, too far away, maybe. I don't know. Whoa, too fast. I haven't got any brakes on this thing yet, so. Ah! Let's add some brakes to this thing. Let's go to my thruster. Right, so I've got my thruster there. If I were to go to my edit project settings and input and put one in for brake. And that'll be the S key. And we change its scale here to -1. Now it should decelerate as fast as it accelerates. And it also should reverse. Don't know. My brake doesn't seem to be working. Oh, I know why. So stupid. I don't want to do brake as a separate number, do I? Sorry, I'm going. It's late. Thruster. The brake would be the S key, and it'd be -1 there. That's what I was meant to do the first time round. Right, push play. Right, there you go. I can stop now. Don't get why it doesn't clamp properly. DPI scaling, maybe? Maybe, but that's what we just tried with the vector scale. If I search for DPI, get mouse position, but that's just mouse position. Yeah, no, the scale is done by Viewport Scale. That. There must be something to do with this. It's the only thing I can think of that would affect it. But I don't know. It's a weird way it does the scaling, because it came out worse. So maybe it's fractional, the Viewport Scale. If it's fractional, then I have to... Yeah, it's a bit worse, that one. Let's try... Rather than multiply, let's try dividing. Don't know if Viewport Scale is... I'll tell you what would be actually easier if I just print string Viewport Scale. .833, yeah. So if I was multiplying by that, that's not going to work, is it? I want to divide by that. So do that divided by float. Then split this y and drag that over here. Okay, moment of truth. Hey, there you go. It's divide. Okay, so it divides. Nice. Okay, so we've got our target doing its thing there. Okay. So my next trick is I want to make it so that the targeting display shows the distance away from the target you are. So let's go to the targeting widget here and add some text above it. So we're going to wrap this with a vector, vertical box, sorry, vector. What am I on? And then put a text field in there. Okay, so the no, I don't want to do that. I want to wrap the size box with a vertical box. There we go. And put some text in there. I'll put it above the size box. There we go. So this text is going to be the distance. So I'm going to put it in here. distance text and tick its variable. Then on the graph over here, I want to get a variable here, and this will be distance. Put that there, and that'd be float. Now, because this thing's going to be updating all the time, it's a lot quicker if I just go in here and just change the text here with a new binding and put in a binding here for it. So now binding is attached to this. So when it updates, because it's been updating all the time, binding is totally fine. So that's that. So we just need to pass through this distance value over to it. So if I make this editable, I think, and then go to HUD, and on the HUD here we're going to get the target, and we're going to get distance 2, target actor, and then the other actor is get player character, and we're going to set the target on our widget. Set distance there. Bosh, bosh. And let's see what this comes out as. Nothing. Brilliant. Okay, so distance there. That bit's working. It's the HUD that's not doing its job. Get distance 2, returns distance from this actor to other actor. So target is target actor. Yep. Don't get what's going wrong there. Hi John. I am Zone, and thank you for the birthday wishes. I had a lovely dinner today with my wife and kids. It was lovely. A little pod thing. It's like a perspex igloo. It's cool. A nice steak. Right, I don't understand what this distance thing is not doing. Let's just print string everything. So the only thing I can think of that may go wrong. Let's make sure it knows which one's a player character. Yep, that's the problem. It's not player character, it's player pawn. Get player pawn. Because the spaceship's a pawn. Okay. There we go. So now I've got a distance notification on my target identifier. But obviously it's always going to be a large number, which is annoying. So what we're going to do see if I can get closer to it. Okay, so what we're going to do is change the formatting of this text to be actually more useful. Okay, so let's do that. On my test target, no, not test target, targeting widget, we're going to go into the graph and go into that get distance text value. Oh, we're already here. Okay, when you've got this to text, if you click open here, you get a load of settings about how you want it to look. So, maximum fractional digits will have 0. I don't want no fractions on it. Integral digit, we've got 1 to 324, which is quite large, obviously. Always grouping. Grouping is when you have like commas in it. Well, first of all, let's see what this looks like. Okay, bit better. Okay, not bad. Okay, so let's fix some flying stuff here because this flying is annoying. It's not good. Okay, so first thing we'll do is clamp this speed can go. So we need to clamp their acceleration. Ooh. See what this does. Got to finish might go very fast. Yep. Let's turn that down. Let's do 100 here. Okay, so we've got some basic acceleration going on there. Right, so the next thing I want to do is on the brake, I don't want it to reverse thrust the whole time. I want to stop it from doing that. So let's do that. Set velocity. I think that's one. No, what is it? This is a clamp on here. Hang on, let's have a look. Constraints. No. Linear velocity. That might be actually more interesting than add force. Let's have a look how that looks. So when it comes to physics-based movement, it is a lot of trial and error to get it to feel right. So sadly, that's what we've got to do. Okay, let's see. So go forwards. Okay, so you don't get no drift, you just moves you. That's not what I want. Unless we do it with a bit of funky lerping to get more like what we want. Now I kind of like the add force mechanic. It seems a bit more drifty and space-like. Let's have a look at chat while I have a little sip of drink. Okay, so let's just go through. Let me do something for you guys and go through how the targeting widget works with regards to clamping it to the screen. To sum up, okay, so the conclusion for the clamping to the screen is this. So on our HUD, we've got a targeting widget, which is the icon that you'd have. And on here, we've got event tick, and we checking whether or not we have got a target. And by default, we set ourselves up a target for the whole entire time. But you may not have a target all the time. So this is what that does. Next, we get the player controller and get access location of the target and project its world location to a widget position. And this is per the player's screen. So if you're doing split screen, you need to tick this box. This gives you a screen position and a return value. The return value means if the projection is off the screen or on the screen. So this is if you want the icon to change, change to different icon, I mean it's off the screen. You can do that. That's what you do there. And then we're clamping it, and we're clamping it by getting the viewport size and the scale and dividing the size by the scale. The scale here is a fractional scale, so we are dividing it by that to get the real size of the screen, and that plugs in the clamps and into our render transform. And at the end here, we're getting the distance value from get distance 2 and plugging it into the text box. That's it. So now, oh, pardon me, we're working on improving the flying mechanic in this game. So I haven't got much longer here left, so let's see if we can get 15 minutes to try and improve this a bit. So I need to limit, I don't want it to go backwards. I need to limit the velocity going out of it. And I'm not too sure how we go about that. So, get force maybe. Get force. No, get. Need to get the. I won't get velocity, but it don't come up. Get the limit. Maybe it's this get component velocity. Let's have a look at that. Let's print string this, see if this is the value we want to change. Oh, hello. Oh, God's sake. Plug that in there. There you go. So, accelerating. Decelerating. Okay, I think that might be it. So can I change that? So if I go from here and go set component velocity, untick that. Do it from component here. Set component velocity. Set velocity and no. Set. No. Oh wait. Set velocity. Maybe it's this one. So if I do that and clamp this, I don't think you can clamp a float, a vector. Clamp size, but no. So I need to split that. So here we want to change the X here and clamp this. 0 and a maximum of 1000. Let's see what that does. Very slow. Oh, hang on, I can move back faster. How's that working? What? Oh, ignore the description, Alec. Yeah, it is live. That's just me being stupid and copying stuff over and not changing it. Why is that backwards? It's easy enough to fix. I can just multiply this by -1, but it's just confusing me why that's backwards. So now I don't be able to reverse. Can't really do anything. Oh, it's because the value is min. Balls. Anyway. Okay. So we'll just put it in there. Change the max here to 0. Minimum to be -1000. So I can accelerate forwards, and I can ideally stop. I shouldn't be able to go backwards. That's correct. Yay, there you go. So I can accelerate forwards. We're obviously going quite slow, but that's fine for our testing purposes. Oh, hang on. No. Oh, I know why it's doing that. I know. The reason why is because velocity is a world location, world space, and not local space. So. Transform direction, and we want to get the mesh. Oh, is one if that would do it? If the get velocity, get physics linear velocity, maybe. Just want to print string this. Right, so that's moving forwards. Going backwards now. Right, but it's printing out values, which is correct. Right. But its velocity is going... No, that's... Wait, hang on. Okay. Very confusing. Okay, if I go towards it, now if I start reversing back up. I don't understand how that value works. Maybe I'm being thick. That doesn't make sense to me. Try a different one. Get... Hi Blitz, I'm not making a full game. We were just doing a test of how to get a targeting reticule to remain on the screen when you're targeting a target in a space game. So like this, where you can see the block remain on the screen. Image, whatever you want to do. So that's what we've achieved so far. We're now just trying to make the spaceship fly a bit better, because at the moment it flies a bit poo. Let's increase this by 500. What do you think of acceleration, maybe? Let's try acceleration. Acceleration. Just floating pawn movement. Or maybe rather than using a physics-based sort of asset, maybe we should try doing it with floating pawn movement. Let's try that. Floating pawn movement. Oh, hello. Acceleration. Oh. I forgot how you do acceleration. 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 Self acceleration. Multiplied by a float. Oh. Yeah, no, that's not it. That's just the setting for acceleration. Just got to add movement in, I guess. Um, add input vector. Don't want that. Being done. Okay, so that's the target there. The world vector is going to come from this. I'm going to multiply this by a vector. And multiply it by, no, just put that in. See what happens when we just put that in. Oh, we've got to stop for simulate physics. Where was it? There you go. Right, better. Right, so I need to clamp that bit, but that's fine. So let's fix the other one. So this might actually work better without the physics space bollocks. Okay, so let's go down to here and let's change this to be actually good. Because at the moment it's poo. By the way, my patrons will get access to these project files after I'm finished with them. That's totally fine. Right, pitch and roll. So this thing is actually going to use the controller's pitch and roll. So use control pitch, roll and roll. So on pitch here, we'll do add pitch. Like so. Your add your and add roll. Ooh. Okay. There you go. Meow. Pew pew pew. All fun. That moves 100% better. Oh, that's much better. We much prefer that. I got rolling. Oh, that is gorgeous. Okay, that's much better. So let's just fix these up here. I'm not happy with this. So rolls, let's switch these background to 1, -1. And I think the pitch felt weird. Hang on, let's have a look. So roll, that's right. Down, up. So I've got inverted controls, that's fine. That feels fine as well. Okay, so obviously this is a bit too erratic. We need to change that to be alert. So let's try this. Yeah, so Alacon, we actually hit our 500 patron goal, which means that there will be an RTS coming hopefully very soon. I'm starting a new series soon for patrons called Stealth AI. We'll be wrapping up Melee AI soon and other things soon as well. The next AI one will be Stealth, so we'll basically remake Metal Gear Solid, essentially what we're doing. Okay, so I need it to drift a little bit when I push go. The moment it just stops. So let's change its deceleration. in the pawn movement here. So deceleration here, a bit too fast. So let's change that to 1000. That should let it drift a little bit. Yeah. Cool. Let's what I'm gonna do here for the braking. Active forward vector here. We're going to clamp this. No, we'll do abs on this. No, not abs. Clamp. Yeah, split it first. Or do I? Let's try doing abs. I think abs are not going to work. If I push backwards, it's going to eventually go forwards. No. It's all going wrong. Okay, don't want that. You want abs this. No, not abs that. What do I want to do? I need to change his velocity. Right, so on thruster here, I'm going to set velocity. The floating pawn movement. And then get velocity. And I want to clamp the size of that. So split, clamp, float, split this. Y and Z should remain the same, a bit much. Min 0, max 4000, because that's the maximum velocity acceleration we got, I guess. No. Okay. We'll worry about that another time. Let's fix a little bit of roll. I do join us on Twitch. Look forward to seeing you on there, James. Okay, so we've got the pitch yaw controller, but one thing I don't like is I want to change the yaw. So I'm not just doing that all the time. So yeah, so let's lerp this axis value here. So f interp 2. The current value is going to be the get axis value. That's not going to be right because that's just this. Right. Is there a setting I could do on here? Just use controller roll. Unless I don't use the controller's roll and I do my own one. Not roll, yaw rather. Change it down to 1, see if that does anything. Because this doesn't have turning, does it? No. See if that does affect it. I don't think it would because no, I could do whatever I want. The reason why I didn't think it would is because we're using the controllers. This overrides this. So when we say use controllers it's going to turn to the your. I know what we'll do. We'll say turn off the your there. Then on the your here, the access value for this will be the current. No. We basically want to get controller. Get controller. No, where is it? Get player controller. Type in your. Get input. No. No. What am I doing? Get. Oh, it's get control rotation, isn't it? Get rotate. There you go. That's what I wanted. Split that. Because I just want a yaw. The yaw is going to be the target. My brain. Oh well, we can't do control. We can't do that because we're not using that. We want to change their rotation. So set your no. Type in your no. Turn. Rotate. How do you turn a floating pawn? Let me Google this one. What am I doing wrong? Add your input. Turn it off. I think that's what we want. So, for example, just plug that in. Let's see if this turns it. Oh, get player controller. No. Your scale. Do 100. Why they're not? Yeah, nothing. Maybe it's just set rotation. And we want to add rotation to it, don't we? Add rotation. Add actor local rotation. Split in the yaw. Think maybe. Let's see what it does. Oh, there you go. Bit better. Go for a nice cruise around. Quite relaxing. I want to change the pitch, by the way, by looks fit, to be more local. Don't want it to be. I need to fix that. So where's the pitch? Pitch. Right. I want this to be local pitch. So Buckminster. Do I have any of my games in the works? I do, actually. In fact, it's still very, very early, so I'm not going to be revealing it anytime soon. Yeah, Alakram. Yeah, stupid chat. Right, let me figure out how to do this one. So I need to find out how you can change the pitch. Controller pitch local. If not, oh, okay. Yeah, okay. So we can't do it that way. We have to just turn off pitch. And it's very similar to what we've got here for the local rotation. Just going to do that. So on pitch, we're going to add local rotation again. And we're going to add in the pitch. So if I rolled up, down, that's limited now. Why is it stopping me from going over? Should be able to do a full. Like it won't let me turn anymore. Why can't I turn anymore? Where's the roll? Should we roll? Maybe to do our own roll then. Okay. We're doing it all ourselves. Turn that off as well. And we're going to do something similar here. Play. There you go. So if I were like this and I move the mouse up, that's right. That feels a lot better now. And to just tidy things up a little bit, we're going to add a couple of variables in here. And this will be the last thing we do because it's getting quite late here. This one's going to be roll rate. And add 2 more. Pitch rate. Oh. Yaw rate. And for each one of these, you just multiply this by the roll rate. And this one we multiply by the yaw rate. And this one is the pitch rate. So now we can customize things for the player based on different rates they have. So by default, all these should be 1 at the very least. But if I want to say have it pitch, let's say roll a bit faster, so do 1.5 there. We're going to do 0.7 there, and pitch will leave it to 1. And now we should find that it turns and rolls and rotates a bit differently. Yeah. Yeah. Okay. Next we're going to do is a thruster boost. So on here we're going to do a simple way of doing this is on inputs. We're going to axis mapping. We'll call this one boost, and I'll make this equal to left shift and scale 1. And in fact, actually, no. Change the boost scale here by 5. So that then on thruster, we multiply this by a float. And we get boost. And we want to clamp that. Minimum being 1. Maximum being its 5 value. 5. And plug that in. So now, that should, in theory, when I push down left shift, boost me. In theory. There's the thing. No. Let's print string boost. Yeah, 5. 5 times that, 5 times that. Hang about. Let's test that out. I think it is. It's just needs to be a bit higher. Or we need to change input vector here. change acceleration here to something else. Or change max speed. We'll just do change max speed. Try and be clever about it. Can't be clever about it. I'll give up. So we'll do it the simple way. Simple, always better. Boost event. We want that to be not an axis mapping now. We want it to be an action mapping. Get rid of this one. Oh. Boost, and this one will be left shift. And then over here, we're going to do boost. And on a boost event, when we press it, we're going to change the floating point movement's maximum speed. Set max speed to 20. We'll do it to 50,000. Otherwise, it goes back to its default, which is 12, I think, 1200. So I wanted that 5,000, not to 50,000. 1200. Okay. So push play. There we go. Now I've let go of it. Yeah, bit of a boost. Woo! Okay. And for the camera to give the indication that you're lagging behind and try to catch up, if you go down to the lag speed here, let's say 30, turn that down to 10, and it tries to catch up to the thing, so if it goes too fast, so boost, it goes, zooms out, and then when you let go, it should zoom back in. Let's make it a bit more apparent. Let's do 5. So normal speed, boost speed. Let go boost. So it's a really simple way of getting that effect without doing any coding. Cool. It was quite fun to fly around him. So that is it for today's live stream. Hopefully you've enjoyed it and seen some stuff that you kind of like the look of. As I said, patrons will have access to these project files. Gold patrons, sorry, will have access to these files after the fact. This video is live streamed, but it is also being recorded. So patrons will get access to the live recording as soon as possible, and everyone else will get in a couple of weeks' time. And there we go. We've got flying around. We've got targeting icons. Yeah, looking good. So once again, thank you, everyone, for joining us tonight. And I'm off to bed. So, good night, everyone. And I'll see you all next time. See you on Wednesday for Wednesday's question time. Bye, everyone.